Hello everyone, and welcome to part 3 in our DO-254 Basics series, everything you wanted to know about DO-254 but were afraid to ask. In part 3 we'll be looking at what does DO-254 compliance entail. And my name is Michelle Lang. I'll be talking you through these slides today. One of the best ways to explore what DO-254 entails is to look at figure 5.1 of DO-254, which I introduced earlier. This figure basically shows the full scope of DO-254 and also puts the scope in the context of the flow of the document itself. But here we're going to be kind of exploring the scope itself, starting from the systems processes. So I'll be using this diagram throughout to kind of guide the discussion. We'll be starting with system process. So system processes feed information down into the hardware domain, into the DO-254 program. And the documents, the kind of equivalent documents to DO-254 that are used as guidance at that level of design, at the systems level, are ARP 4754A and ARP 4761, which has an A revision in progress right now. So those are the pertinent standards for systems development and systems safety. So what happens at those higher systems levels is that they'll identify the requirements that need to be handed down to the hardware item. And those requirements come in the form of functional requirements and also safety requirements. So the design assurance level is handed down as well. So during the DO-254 process, there can be iterations with the systems process, and that should happen anytime there's a modification or a new requirement added that could have some sort of effect on the system function or system safety. The real start of the DO-254 program is at the planning stage. So planning is the first step of a DO-254 process, and during this time the DO-254 applicant and the team of folks working on the program will develop a set of planning documents that capture the how. So if you remember, we talked about DO-254 being an objectives-based document. So what you have to meet is specified in DO-254. How you're going to meet it is specified in your planning documentation set. The main planning document is called the Plan for Hardware Aspects of Certification, except nobody calls it that. Everyone calls it the PHAC. So you'll hear that term thrown about, PHAC this, PHAC that. That's really the main, sort of the umbrella planning document. The PHAC provides an overview of the compliance process, and it basically references all of the other appropriate secondary documents that kind of provide the next level of detail down in terms of, again, how you're going to meet the DO-254 objectives. At the end of the planning process, this is when you'll typically experience your first audit. These audits are called stage of involvement, or SOI audits, or SOI meetings. So SOI 1, the first of usually 4, is held at the end of the planning process, and it reviews the PHAC and other pertinent planning documents. Now, the DO-254 lifecycle is kind of split into several processes. We just talked about planning. The next kind of portion of DO-254 is referred to as the hardware design processes. After we go through the hardware design processes, we'll talk about the supporting processes. The hardware design processes tend to proceed somewhat sequentially as depicted in the diagram here, in diagram 5.1. The first of these is requirements capture. So requirements capture is the first stage in the hardware design processes, and here is where you get those requirements handed down from the system level. Those get captured, so they're the starting point of requirements for the hardware item developed to be DO-254 compliant. The team then begins to break down these requirements, expand upon them. And during this process, there's a requirements validation process that occurs alongside of this. We'll talk about the supporting process of validation in just a minute. But DO-254 programs are requirements-based programs. Requirements are at the very heart of what these flows, these life cycles are all about. So writing precise, unambiguous, unique, complete, and testable requirements is very, very important. And so the process of making sure that happens is called requirements validation. Now, iteration with the requirements capture process, even during the hardware design flow, occurs anytime a new requirement is derived. So a lot of times you'll hear the word derived requirement. That means as you're progressing through the design flow, you make a decision about how you're going to implement or architect something, and that decision can have a bearing. It's important to understand. It has influence on other processes. So anytime that happens, that new requirement is called a derived requirement, and it needs to go back to the requirements capture phase and go through the same process. Now, anytime any of those derived requirements could impact the system level or system safety, then that's when you need to iterate back to the system processes for some sort of review as well. The next stage in the DO-254 lifecycle, in terms of the hardware design processes, is called conceptual design. Here in conceptual design, it starts by being handed those validated requirements that are pertinent to the hardware item. And then these get formed into the design concept. This is typically depicted with a block diagram that has a high-level description that describes the function of each of the blocks and then the interfaces and interactions between them. And as part of this design concept, the system safety requirements need to be fleshed out and described as well. How those are going to be met needs to be described in your design concept description. The next stage in the hardware design processes is called detailed design, and this is really kind of the meat of the design flow. In what's typically, an FPGA development, here's where you're going to be doing the coding, writing your HDL code for each specific requirement. When the design is fully coded, then the design will be synthesized into a technology-specific netlist. The second audit, SOI 2, is typically held when the detailed design is solid, when it's baselined, and the set of requirements is stabilized. The next stage of the hardware design processes is called implementation. Now, implementation varies quite a bit in terms of whether you're designing an ASIC or an FPGA, but because FPGAs are by far the most common sorts of devices used in aerospace designs, we'll focus our attention on that. So for FPGA design, the netlist at this point is typically taken through a series of back-end processes. So placement and routing and optimization for the specific fabric and turned into a device-specific bit stream that then gets loaded into or programs the FPGA device. So that all of those back-end processes are considered implementation. The final stage of hardware design processes is called production transition. To get from controlled design source to the exact same programmed FPGA time and time again. So repeatability is essential here. And this needs to be demonstrated in an audit. Typically, the SOI 4 audit is held to see this demonstrated. Now moving along to the supporting processes. So what we just went through was sort of a sequential flow of hardware development. But alongside these are what we call the supporting processes. These are ongoing and interacting, active throughout the DO-254 lifecycle, throughout the hardware design processes. The first one we're going to look at is validation and verification. So validation and verification, often called V&V, are blended together into one category, oftentimes, even though they are somewhat distinct. Let's try to clarify them a little bit. So validation means ensuring that the hardware device being developed is being developed with the right set of requirements. So the question we're answering here is, are we building the right thing? And validation plays a very key role at the very earliest stages. Remember, we talked about requirements and the importance of those, making sure they're clear and unambiguous, really working over those requirements to make sure that you're going to be building the right thing. And then towards the end of the process, validation is there to serve the role of making sure that that thing really is the right thing. It does what it is supposed to do. Now, verification means ensuring the device, as it's being designed, meets the requirements. It assumes the requirements are the right requirements, And what it does is it tests the device to ensure it's meeting those requirements. The question verification is answering is, are we building the thing right? So we know the requirements. Now we're building this thing. Are we building it right? Verification tends to occur more uniformly throughout the development process. At every level of design, what is being designed is being verified. The third SOI audit, SOI 3, is typically held to demonstrate both simulation results and target testing. So it's sort of in a modeling environment and also the physical device itself to make sure that the device that has been designed or is being designed truly is performing its intended function. And that intended function is defined by that validated set of requirements. The next supporting process we're going to be talking about is configuration management. The role of configuration management is to ensure that every important piece or item of the DO-254 program is kept under control. In other words, if you have a document, a data item, design object, or a tool that has some kind of significance in terms of meeting DO-254 compliance, that it has to be controlled, kept under configuration management. And this means ensuring each item has a unique identification, is under version control, is under access control, and is archived for potential future retrieval. The next supporting process we're going to talk about is called process assurance. So process assurance, this is sort of one of those thankless jobs. The team, there's usually an individual who performs the role of process assurance, and the team is usually hating this person, but every now and then loving this person. The issue here is that the role of process assurance is to ensure that the team is meeting plans. So everything that was documented in terms of your DO-254 compliance plans, making sure that that is being done. Now, anytime something isn't being done, it is the role of the process assurance manager to make sure that things get fixed. Typically, they'll do this through running mock audits prior to the SOI audits. And it's the hope that through this process, the process assurance manager will find issues before the certification authorities find them. And herein lies the love part, because definitely you want to hear that there's issues and fix them from the process assurance manager rather than the certification authority. The final supporting process we're going to talk about is called certification liaison. Now, I've referenced certification liaison numerous times when I've been talking about the SOI audits. So certification liaison is a process of interacting with the certification authority, either those directly working from the FAA or working at the FAA or EASA, or whatever other agency you are interacting with, or through their designated representatives. And in the U.S., those folks are typically called or referred to as DERs. The certification liaison interaction typically occurs during these various SOI audits. I described already there's typically 4 SOI audits. There might be less for a very experienced company, might be more for an inexperienced company. It kind of all depends on the needs of the program and the company involved. But there's also ongoing communication throughout a program, phone calls, emails, and a lot of this, how you're going to interact with certification liaison tends to be part of what you specify in your planning document. So in summary, what DO-254 entails is really nicely encapsulated in figure 5.1 of DO-254, which we just talked through. So, how to learn more? Well, you can finish watching the final videos in the DO-254 Basics series or other related videos on this channel. But again, I can't emphasize enough how important professional training is. DO-254 is all about experience. So if you don't have that experience, you need to leverage the experience of others, seek training, get some experienced folks working on your team, help you break down that huge barrier to entry, that big cost of that first program. Another thing you can do is visit logiccircuit.com, download the white paper DO-254 Basics. That is the white paper from which this video was derived. And again, my name is Michelle Lang. My email is down there in the bottom left. And if you have any questions, you can always shoot me an email. Thanks a lot.